Two objects are at rest on a frictionless surface. Object 1 has a greater mass than object 2. So we have the following situation. We have something like this. So two objects, this has greater mass than the other object. Okay. The other object is smaller. Object 1 has a greater mass, so we can call this as M1 and this is M2. So both are at rest. So we are talking about 0 over here. Okay. When the constant force is applied to object 1, it accelerates through a distance of d. So it from here till here, right, this distance happens to be d. So we are pushing from this point to this point. So this is d. Next is the force is removed from object 1 and is applied to object 2. So this is object 2. At that moment, when object 2 has accelerated through the same distance d. So this again is the same distance d. It's a pretty good question actually. So, okay, which statement or statements is true? There's one more part that has to do with kinetic energy. I removed it. We'll be having that conversation later. Yeah, guys. So basically, which has more momentum is the question. So you can pause and take numbers, put values for all of this. Take force as 10 Newton, mass is say 1, this can be 2 kg, this can be 1 kg. The distance over here can be say 1 meter, and check things. Figure out final velocity and so on and so forth. Or we can do this method. So we know that impulse is given by change in momentum, and this in turn is given by force times of delta t. Change in momentum is final momentum minus initial momentum by force times of or t or delta t, doesn't matter. Now, in both the cases, or let me go case object 1, what do we have? The final momentum of 1 minus the initial momentum is 0, and this force is F delta T1, right? Force is also constant. So I'm just taking it as F, right? And the initial momentum is 0. P of I comma 1 is 0 as initial velocity of 1 is 0. We have case wherein we have the object 2. The final velocity is there, but the initial velocity is 0. Force is same. And delta T2. You guys agree T2 will be different? The times will be different? Yes or no? Okay, I'll be asking that question actually. I'm not explaining that part for a reason. So initial momentum of this also is 0 as its initial velocity is 0. Okay, guys. Now, we are trying to compare PF1 and PF2. So this will be F into delta T1 divided by F into delta T2. So F and F gets cancelled, and basically we have this ratio. delta T1 by delta T2. So basically, if we understand this relation, we will be able to figure out this relation. See, don't think too much. Don't think numerically. Yes, I had to show numerically, but let's use common sense. You have to push a heavy object. You alone are pushing. Here too, you alone are putting the same effort and pushing a lighter object. Say you pushed here for 1 meter, here for 1 meter. Now the question is, as per whatever we ended up with, we are looking at time. I'll ask you guys a simple question, which will take more time? Which will take more time to push through the distance of d? Yes, obviously the heavier object. And so, as delta T1 is greater than delta T2, this is because the heavier object takes more time to push. With the same force. That is important. If the force was not the same, then things will not be of this discussion. This implies PF1 has to be greater than PF2. Oh, we called it as F1, F2, but okay. You guys understand that. Right? So all this mathematics is just to end up with this expression. You can cut short all of this writing, provided you have a good funda. You have a good grip on the basics, then you'll be able to come to this expression directly. That will happen in time, but for now you guys copy everything on the screen, learn to think systematically, then in time you'll figure out the shortcuts. Okay, don't bother with the shortcuts now.